So just real quickly, who am I? Who is Sodexis? This is kind of the agenda. I'll talk about what RUM is. I think you guys get RUM, so I don't think I'm going to spend a heck of a lot of time about that. I'm going to talk a little bit about our particular brand of RUM. What we do with it is a little bit different than, say, what SOSTA does or some of the other companies that do RUM. And then I'm going to talk about micro-outages because it's something that we've seen everybody sees the big outages. Because of the number of measurements we're doing and the way we're doing those measurements across all the types of infrastructure on the internet, we see outages that a lot of people just frankly don't see. And then I'm going to give you lots of examples of that. And then I have another section called Other Interesting Anomalies on the Internet, which is just a bunch of weird stuff that we see that you guys might find interesting, or you might not, in which case don't ask any questions and we'll go through it quickly. So who am I? That's a picture of me. It's kind of like a driver's license thing. I was a developer when I first started out. I worked at IBM, then I worked at a number of other companies. You can probably hear from my syrupy accent that I'm from the South. I'm from Atlanta, Georgia. I was the CTO of a company called, in 2006, Multicast Media, which is an OVP platform along the lines of Brightcove or Kaltura. We had 3 different CDNs, so that was my first experience having to federate across multiple CDNs. We did it in a very, very caveman kind of way. We literally, I just had different clients on different CDNs, right? So I had 2,000 or 3,000 clients, and the first, 1,100 went on one, the second went on the next, and the third went on next. We sold that company to Kit Digital, and then I joined Internap and became the vice president of their CDN division and ran that division for 4 years. And then early this year, I decided I was much happier doing high-tech startup type companies, so I joined Sodexis. So that's my story. Who is Sodexis? Sodexis. How many people don't know at all who Sodexis is? Okay, well, good. I'm glad I had the slide. So the 2 founders of Sodexis, these 2 guys here, both came from Akamai. And back in 2009, or really a little bit before that, they came up with this idea of, using RUM measurements to direct traffic to the fastest piece of infrastructure. And so they went into a development mode and developed on that for really a couple of years. The guy on this side is Julian Colon, and he's in Paris, and he was a sales guy, and he's actually still the head of sales for our European division. And so he started selling the product in Europe prior to anybody in America selling it. So we've actually got quite a few customers that I'll show you in a little bit on another slide from Europe, rather large companies, and those became customers because primarily we were selling there about 4.5 years before we even started selling in North America. The other guy, Marty Kagan here, is the CTO, and he lives in Portland, Oregon, and that's why I said a minute ago we are hiring developers in Portland, Oregon. And the rest of the guys you don't care about. We do have offices in New York. These guys back here are our New York office. Portland, Chicago, San Francisco. I'm being very vain by saying Atlanta because I happen to be the only guy there. So it's kind of just my joke to myself. We've won numerous awards because of the technology. And so anyway, that's who Sodexis is. So we really have 2 products. The first product is free. We give this away for free. It's called Radar. And essentially, it gives you the ability to take a tag, put it on your website, and for $0, get every performance characteristic of that website with regard to latency, throughput, first byte delivery, all that kind of stuff, right? The reason we give it away for free is we can anonymize those measurements and then use them in a pool. And the way we use those measurements is for the OpenMix product, which we won't talk about tonight. OpenMix is our commercial product. That's how we make money. And we signal process 2.5 billion measurements a day from every ISP in the world. And those measurements are of infrastructure such as Akamai, Limelight, Level 3, Internap, Highwinds, every CDN in the world. And we also measure every cloud instance in the world. So AWS in Virginia, AWS in Oregon, AWS in California, Rackspace and all their locations, Internap and all its locations, et cetera, et cetera. We take all those measurements and we signal process them down and rank them based on score. So for instance, New York, Comcast, we know what's the fastest CDN right this second in New York for Comcast. Likewise, we know the same thing for AT&T. And we know the same thing for every geolocation and every ISP in the world. So that's what OpenMix is. We're not going to talk about that a whole lot, but that's the reason that we get the radar measurements. And we are going to talk about the radar measurements because that's sort of the interesting stuff, at least the stuff I find interesting. So just to give you an idea of the number of customers, again, essentially these are all examples of customers that have deployed the tag. We've got over 500 customers that have deployed this RUM tag. And some of them are, we also have a mobile SDK, so we have iOS customers and Android customers as well. And those measurements are against every piece of infrastructure on the internet. And again, you know, right now the numbers are running at about 2.5 billion. It grows all the time. Since I've been here, it's grown significantly. And I've only been in the company for, whatever, 6 months. And what we get out of that is availability, latency, throughput, dynamic delivery, SSL delivery, and mobile delivery measurements. In this particular example, you can see that in the US on this particular day, Max CDN had the lowest, latency for milliseconds. Now the reality is the differential here is very little, right? The difference between 44 and 47 is extraordinarily small in terms of milliseconds. You go to Asia, South America, the Middle East, those differentials get quite a bit different. And we'll show you some of that. So what is RUM? Again, just to give you, and I'm trying to rip through this part quickly so we can get to the interesting stuff. But essentially, we deploy the tag. The tag happens on a page load. So, for instance, Bloomberg is a customer, right? They've deployed the tag. If you read Bloomberg this morning, after your page load completed, the tag woke up and said, okay, let's measure Akamai from wherever you're, whatever ISP you're on, whatever coffee shop you're in, et cetera, et cetera. And it took 3 measurements, maybe. It is an average number of measurements. We do about 500 million sessions a day and get, like I said, about 2.5 billion measurements a day. And so why do we like RUM? Again, I don't think I have to tell you guys this, but essentially it identifies problems that you can't see with some types of synthetic monitoring, mostly last mile, right? Synthetic monitors are typically sitting in data centers, highly connected data centers, an Equinix data center for perhaps, it's measuring some important stuff. And our APM like Catchpoint partners are great additions to what we do. So this is no slam on them at all. But the RUM measurements that we get just measure a different stuff, and we see things that they don't see. We can see both cellular, broadband, in-user device, and the last mile. So anyway, that's the commercial. Now let's look at the data. Oh, I do talk about, so what is a micro-outage? A micro-outage is essentially something that, if you think about what a CDN is, and by the way, I'm gonna focus on CDNs tonight because clouds aren't that interesting. If you think about it, a cloud lives in a certain location. It has a certain connection to the internet. Maybe it's multi-home, maybe it's not, but most are. But if it goes, everybody knows when they go out, right? The CDNs are more interesting. First of all, they're built to not go down, right? I mean, Akamai's built to not go down. Limelight's built to not go down. And so when they do have failures, it's really more interesting than when a cloud has a failure. And what I tried to list here was a partial list of some of the reasons CDNs fail, right? And if you've been a customer of a CDN for long, you've seen one or more of these. If you've been within a CDN, you've probably seen them all at one point or another. In fact, I'm actually writing a blog on this that I'm going to give away some T-shirts to people who have the best, most interesting outage stories. But I kind of primed the pump with some of these, and I personally have seen most of these as well. And so, essentially, if you look at them, a single pop going out, that's going to not necessarily take down a site. However, it will add latency. If the pop happened to be in Boston and now all that traffic gets redirected to New York, obviously there's some additional latency. That's not too bad between Boston and New York. If it happens, between Singapore and Hong Kong, it can be a little bit more damaging. Other problems is, when you have caching server errors, bugs are introduced, or you have, for instance, if your SSL map starts to have problems for whatever reason. Typically, an SSL map is a little bit smaller than the HTTP map of a CDN, and so when when you have certain value-added features that are not distributed as widely as everything else on a CDN, you can have issues. Other kinds of issues are DDoS. You can have regional attacks on DDoS, or you can have anycast route misconfigurations or GeoDNS problems that take your whole CDN down. And there's well-documented examples of that. These type of outages I'm not really that interested in. It's more the micro outages, and I'm going to rip through this. I'm going to slip forward right here because it's exactly where I want to get, because this is actually the interesting stuff in the talk. So this is first of all a self-definition. Not a whole lot of people are talking about micro outages. So there's a certain element to where Sodexis is making this up because we're seeing something that not many people talk about. And so one thing what we're talking about here is essentially a 10 consecutive 1 minute average when they're significantly lower. And we're talking about availability here, right? So if you think about availability, most people think availability is on and off, right? Well, it's not. Availability is you're attempting to connect, right? You're attempting to connect to the CDN. If 8 out of 10 connection attempts succeed, you're 80% available, right? It's just that simple. So availability is not on or off, it's actually a percentage. And in this case, we're looking at if your typical availability runs at, Akamai has a very high SLA on availability. So in the continental United States, and as do most CDNs actually. And so what you're looking at there is when it drops below the threshold of what's average. So if the average is 99.7% availability and it drops to 95% availability, bang. And if it does that for 10 minutes, that's a micro outage. This is actually a real breach. Something I've done here on all these breaches, I've redacted the names of the CDNs, and the reason for that is our CDNs are our partners. We're not out to blast them at all. What we are out to do is really help them, become better and help our customers understand the value of a multi-CDN strategy. So I'm not gonna name names. Yes, sir. So from a RUM perspective, the two are virtually indistinguishable. But it doesn't really matter, right? What matters, and so this is where the synthetic monitoring tools in my mind and the APM tools really take a forefront position, right? We can detect the outage, but the why part, a lot of times that's on the inside of your network. If you're monitoring the routers and you know that they're overloaded, then you're right. But most of the large broadcast type environments that, like what you're referring to in the Super Bowl, they're all using multiple CDNs today. Not all, and the reason they are is because of that exact issue, which is they want burstability. If you've there's multiple scenarios. This is a long conversation. If you're not using a CDN, for instance, sure, your servers are going to go down because you're hammered. If you're using a single CDN that doesn't have the capacity to deal with those requests, it's going to go down. That is a fact. The reason it goes down, and CDNs are multi-tenant, right? So you have to realize that. Someone else might be bursting and you're affected. So what RUM successfully measures is the fact that these things are happening. Correct. And you're absolutely right. But here's my one issue, or I guess my response to that is, if you're an enterprise customer, you've got no way to know what's happening under the covers of the CDN. All you know is that CDN's now giving me poor performance. Another example is the Apple streaming the event, a month ago. And so that's another good example of them actually introducing, I think it was a chat feature without load testing it. So, there's a million, you have to load test. You got this group, I don't have to convince anybody in this group you got to load test. Sure, so an example is if you're building a hybrid CDN, or if you're building a hybrid delivery model where some of your stuff is delivered off CDN and others are delivered off your own varnish servers, right? You might have Catchpoint, for instance, or Soast, or some other, you might have an APM tool monitoring those servers. OpenMix can ingest that data, right? It can also ingest the RUM data and then make modifications it can do the traffic management based on really a variety of things. So, synthetic or RUM. But I'm mostly here to talk about RUM tonight because it's what the data we have. But yeah, our solution can ingest synthetic, absolutely. And I believe it's a very important part of the puzzle. Yep. Oh, yeah. Well, in this case, yeah, I'll actually have a slide on this in a minute where I show the relationship of availability to latency, and there is a very strong correlation. Basically, the lower your availability, the worse your latency is generally true. Now, you can have actually very good availability and still be slow as hell. right? It turns out that, having great availability doesn't make your network faster, but if you have poor availability, you will definitely be slower because it's just common sense. You're making multiple connection attempts. Your browser's trying, 5 times out of 10 to try to connect to something, right? And so you're going to have a slower experience. So the answer is generally yes. Yeah, I'll give you an example. You're exactly right. I'll give you an example in our charts where who remembers the Time Warner cable outage here in New York about a couple of months ago or something? Sorry, but so. But there was a time and there was actually a point in time. You'll like this slide actually. Akamai was the big winner on that slide because it actually you guys improved performance. You're correctly connected to them so that when that outage happened. So we'll answer that in a minute. But you're right. Generally speaking, if there's zero availability, which is pretty rare, but if there's zero availability, well, I mean, if you get a backhoe across a piece of fiber. But usually that reroutes even, so I mean it's not as common as you'd think. But you're right, zero means no measurements. So yeah, you get the point. The page loads, and then at the bottom of the page is the JavaScript, and it wakes up and says, okay, let's see how level 3 is doing right now. Let's see how Internet's doing. Let's see how AWS is doing. Yeah, but they capture the geolocation, the IP, and the specific ISP or ASN that user is on. And then it measures it for latency, throughput, and availability. All right, so basically taking that same outage that you were just looking at and applying a heat map to it where 100% is green. So 100% availability is green. Yellow is about 75% availability, and then dark red is you're really hurting at that point. What we see rolled up for that particular outage was North America was yellow. So if you think about all North America, which includes Central America, as yellow, you're talking about a fairly significant 75% availability for the entire continent. And then if you drill in, these are the countries that were affected, the top here, and you can see for that period of time, right, essentially in the United States, there was 75% availability for this micro outage for roughly 10 minutes. And in Mexico, it was extraordinarily red. And then if you drill down to the next level, you see these are the top talker ISPs. And if you look at the bottom, you can see in the United States, and in fact, you can see, specifically Mexico and the United States down here. You see how I believe this one is Sprint. And so there were specific networks that were impacted. This particular one, and you'll see some others in a minute, this particular one is actually fairly intermittent, meaning during that 10 or so minute time period, there was actually moments in time where it popped back to green. There was a whole minute or so where you were getting, thousands of significantly good measurements, and then it would drop back down. Why I listed the list of particular outage types is it's what I'm trying to do in my mind is correlate those outage types to what I'm seeing here on these heat maps. I think this could be a variety of things. This could be caching errors. This could be, I think a DNS error is possible here, or routing issues. It feels like that. I'll show you one in a minute that feels like it got a fiber cut. I mean, it's literally green to red, and then 15 minutes later, somebody figured out something, or they turned a router off or something. So that isn't, so it's, I don't know exactly how many measurements, but it's a couple thousand measurements. Yeah, it's a couple thousand measurements per minute per ISP. And some of the ISPs are more, like Comcast, obviously. We get an awful lot of Comcast measurements. Some of the more obscure ASNs, we don't get quite as many. Yeah, this is a roughly 10-minute time period of where, from the time in which it became intermittent to the time and point where it completely cleared up. This is an interesting one, though, because of the intermittency and because the ISPs all dealt with it differently. Some of these ISPs, like Jazz Telecom in Spain, had really zero problems, right? Of course, they wouldn't necessarily because it was primarily more in Europe, but even some of the North America didn't have as much of a problem. MCI came out pretty unscathed. They only really had 1 minute of kind of 75% availability. So the next one happened in Europe. This was a roughly, no, somebody have a question? No? A 10-minute one. Again, I roll this up to here. If you drill down to the country level, France was impacted heavily, right? So, again, all of Europe was yellow, but then if you drill down at the country level, you see France. And then if you drill down into France, you can see this one had a pretty stark, delineation. And then what I find interesting is the free SaaS, the bottom ISP, really went on for another 10 minutes after most of the ISPs had cleared up. To me, that feels like perhaps these guys are the culprit. I mean, if I had to guess, right? It's interesting I'm very familiar with the ISPs in North America, but some of these European and especially more the ones in Asia, I'm not as familiar with. So understanding some background on some of these is very interesting. But this one's interesting because again, it all happened very quickly. If you remember the other one, there was kind of a lead in on the front end, and I'm trying to figure out in my mind, and we've got people smarter than me trying to figure out because we'd like to categorize these in by the type of outage, because that would help us help our partners. Yeah, there's actually a slide where we have a list of ISPs over a 24-hour period, and then sort of their availability characteristics as measured against all of our infrastructure. And what you'll see there is there's a diurnal kind of pattern, and for sure, I mean, certain networks don't upgrade as fast as others. The orange is the example there. They clearly get really busy early, and at least on that day, on the 24-hour period that I have measured, they're red hot for, a significant 12 or 10, more hour period of that time, and it has an impact on latency. So, the last one of these I'm going to show happened in Asia, and I like this one because it's very different from the others. You can see it has like a hard stop, a hard start, right? This was good, not good. And this was not good, good. And did somebody unplug a router? It's kind of hard to say, but if even drilling down to the country level, that pattern stays pretty consistent. And what I find interesting is essentially the different countries that avoided it, and the countries that were impacted. And Vietnam, for instance, being really only 75% available. That tells me that maybe they're multi-homed in some kind of way that some of these other guys aren't. Cambodia looks very good. Not sure why. Yeah. And then you see the same exact pattern in here. And again, that tells me, I really don't think it's a fiber cut, but it does look like somebody unplugged something. Well, yeah, so you're saying there's dual cables and then someone had to change a route. And when they changed the route, it came back on fast. Okay. Well, yeah, the one reason I had thought about discarding the fiber cut was that how fast it came back on, right? Because even if you reroute something with BGP, you got a 5 or 10 minute route, that populates out. It doesn't immediately flip on. So a cut would take longer the cut would take longer on the back end, is what I was thinking. Yeah. So then we had one outage. So just to give you what I guess I would say is a compare and contrast, right? What I've shown you is what we're calling micro-outages. They impacted maybe a single spot for some period of time, only a subset of the ISPs, only maybe it was regionally encapsulated. What I'm about to show you is one that happened in the summer that was not that way, and so this one has a little bit uglier, right? And this was a major CDN outage. It impacted, and it was the entire CDN that went down, as you can see, and it was down for a pretty significant period of time. I didn't. The heat map for this is taller than me. I mean, when you actually, so there's no way for me to represent it on a single slide, and I didn't want to go through 15 slides. But this gives you an idea of the ubiquitous nature of that and what it looks like. And this is really not what we're talking about as much when we call micro outages. This is an example of there's just an outage. This is when a CDN has just fallen down and can't get up. And this particular outage, the average availability was about 11.45% across the world, across every ISP. So that's bad, right? And that kind of helps answer your question of, well, what if it's completely off? It wasn't completely off, and so we knew that there were enough measurements to know that something was there. There was also about 2 million measurements taken during that time, and the duration was about 45 to 70 minutes. So I talked earlier about, I'm going to show you a different kind of slide. So what you're looking at here is the same kind of metric, right? The same availability metric, but instead of looking at a single CDN or single cloud, I'm looking at all of them. So we have about 100 plus pieces of infrastructure in the world that we measure, right? And so what we did was we aggregated that across our top talker ISPs over the course of a day. So this is 24-hour period, right? And if you notice, this is Orange up here, actually, for whatever reason, they're not having a happy day. But you know, some of the others are having problems too. These guys down here, I'll bring your attention to Cablevision, which is, you know, they seem to have really strong availability. So I'm going to flip to the next page. I'll flip back and forth a few times. Talk to me afterwards. Yeah, I'm perfectly happy. Actually, I've blogged it, but I can give you a high def version of it. Happy to do it. So this is the RUM measurements for availability. So I'm going to flip it, and you're going to see the RUM measurements for performance or latency. And oh, one more thing I wanted to bring your attention to. Look at this big yellow area, which is kind of the diurnal area that we discussed, right? That's where, you know, they go to green to yellow and back to green again. And you can see that's exactly where the performance problems start to happen. And this is measured, I think, from 40 milliseconds to like 150 to 200 milliseconds. It's kind of the range from green to red. In this case, they were just top talkers. They were you know, we have 40,000 ISPs. These were the ones that on that day we had the most. These were the top. These particular ones were the top ones. That's why they're all over the place. And sure, oh yeah, I mean, literally, this is a slide that's, you know, it would start up there on the roof and go down. It's 40,000 lines. I mean, there's, you know, there's some, we currently in our online reporting roll up, I think, per country, everything after the number 3,000 ISP. We just roll it up into other, but you can get the data. So the data's still there, but it's just from a display perspective, you can't possibly, and most of them you don't care about. I mean, you don't care about the public school system in, you know, whatever, you know, Atlanta, Georgia or something. They have their own ASN, right? So they get listed. So you want to exclude those for the most part, even though you do get measurements from those. Those teachers are out there looking at stuff, reading Bloomberg, I'm sure. So I find that very interesting, and that, to me, in my mind, that very much illustrates the relationship of latency to availability. But so anyway, speak to me afterwards, and I'd be happy to get it to you. So what happens when it's not the CDN, right? Because I think, you know, this is an interesting one, and you know, there was an outage. It was well publicized, so it wasn't us calling out, but we did write some blogs about it. And what we saw at the time was, I'm going to show you, for those who don't know, TWC has, and many networks do have multiple ASNs, right? So my old company, Internap, they had 40 ASNs or so, and you know, TWC has a number of them. And so what I'm going to show you here is only the top four, or the four of the ones that were actually interesting. And just like I can look at a single piece of infrastructure from multiple ISPs and determine that there's a micro outage of that piece of infrastructure, whether it's a CDN or a cloud, I can turn that around and say, hey, if I've got multiple pieces of infrastructure that are all having the same experience with a particular ISP or ASN, then I can know that there's a problem with the ASN, right? So in this case, I happen to choose Fastly, Level 3, High Winds, Limelight, and Akamai. But you know, it could have been any of them. Could have been AWS. It could have been any number of them. And what you see on this particular ASN, which is ASN 2000 or 20001, is that actually on this particular one, Fastly almost had the best number, and I think maybe High Winds came in there, but everybody was impacted pretty significantly. When you jump from 50 milliseconds to over 100, or you know, in some cases over 150, that's a pretty significant differential, right? And that's inside the continental United States. That's not worldwide. These measurements were all taken from inside the U.S. So at that point, you're having a pretty big impact on a page load time. This one here, and this is to point. This is ASN 12771. It had significant breakages, and this is one I was referring to where Akamai actually came out the winner. It actually had a increase or a decrease in latency, right? A significant decrease, and I attribute that, and I'd love to hear from somebody over there confidentially, is we cut the cable. You cut their cables, right? That's great. That's great, but you clearly, I will say this, clearly you're peered correctly. Clearly you're embedded in their network in a way that the other guys are not. And my take on this is when these guys got cut out, that pipe got real empty. And Akamai all of a sudden said, hey, we're fat, we're not sharing it with anybody. So bang, their latency actually went down during that time period. Similar result here. These guys didn't get completely cut on this ASN. Their latency went way up. Akamai's actually went down in that particular case. And then the last one is more of a mixed bag. All the pieces of infrastructure felt it. So that's one of the areas we're exploring, which is how do you tell when it's the ASN's fault or the ISP's fault? And this is the mechanism by which we're doing that. And right now our rule of thumb, and we're probably using clouds more than CDNs, although again, CDNs are a great use case because they stay up far better than clouds, because they're meant to, right? That's the whole purpose is that they're always delivering something no matter what happens, for the most part. So in short, on this part of the presentation, we see about 150 to 300 of these a month, right? And it varies, right? When I first did this back in March or April, we were seeing a ton of them. It has slowed down. I don't know why. I have to do it for a couple years to understand that, right? To understand if there's some kind of pattern in more micro outages or less. I do believe there are elements like that are as significant as anything. And are you going to have more sites going down during Christmas? Of course you are. Are you going to have more sites going down during Mother's Day? Of course you are. So, or certain kinds of sites, right? So I think you're going to have to, I'm going to have to study this for a while to figure out what the patterns are, but at least identifying and classifying what, the measurements. We're in the beginning stages of it. For the micro outages, since I've been measuring, on a monthly basis, about 25 to 45 hours of outage. That's hours of outage. That's across every CDN in the world, every nation in the world, right? But that's a lot of time. Obviously, a lot of people affected. So that's the micro outages. Before I jump into other stuff, are there any questions about that? Yes, sir. So that's a great question. So let's start with an assumption you're making, which is I know all the mappings of the BGP mappings. I can find that out. Obviously, I can poll routers, but we haven't correlated this data with BGP routes either. I mean, it is a user on that ASN or on that ISP that's looking at Bloomberg or looking at spill games or playing a game or doing something that's causing a page to load that takes the measurements. And so what we know is where you're at, what ISP you're on, but I'm not taking that and figuring out what is the routing, what routes are being published by this network to this other network. One of the challenges that we have as a company is that we have so much data that we have to age it out. Otherwise, it gets extraordinarily expensive. And so, we have an age out process. You get very, very detailed data for 24 hours. Then you get somewhat detailed for 7 days, and then, a month, and then 3 months. And then after 3 months, it's gone. So it makes my job interesting because I got to catch stuff really quick. Like the TWC stuff, I had to catch it when it happened, and I actually, we have an SLA product that's coming out in about a month. And it actually takes snapshots. And the diagram where you saw that went underneath availability, one of the first ones, that's actually from that, where it's actually taking a snapshot of the data and keeping that sort of forever. So we got stuff like that coming out. But right now, if you just took our raw data, it ages out over time. So some other interesting stuff. So I was looking around at ISPs, and I categorized ISPs. And I said, well, let's look at the major ones versus the rural versus the wireless. And I ran this report, and I was like, holy crud. Look at Google at the 50th percentile versus Google at the 75th percentile. Why would that be so different? Why would Google on September 9th of 2014 had that big a differential? Sprint you kind of expect, and do note that there's a different scale between 50th and 75th percentile, so it doesn't exactly measure exactly right. But for sure, the difference in Google at 50th and 75th is stark, right? The people in this, the 25% of the people between 50 and 75 are really getting a raw deal, right? If you're in that first 50% of those people, you're getting a great performance to those 5 CDNs, right? Those are the 5 CDNs we measured it against from, these ISPs. So I actually I got curious, and I took measurements over the next 3 days. And what I saw was, over the next 3 days, I just happened to catch Google. Is anybody from Google here? No, that'd be really cool to figure this one out. But over the next 3 days, Google was able to lower their 75th percentile against these CDNs, whatever, by hundreds of milliseconds. I'm almost certain if I went and took this measurement today, Google would be down here at the 75th percentile. So anyway, I just found this interesting that we kind of caught them in the act of tuning their network. Yeah, I think I caught them when they were tuning their network. I don't think I caught them testing anything. I think they just happened to be I'm sure. I think Google knows what it's doing. I just think they had deployed they were. Oh yeah, significant over 3 days, a couple hundred milliseconds. So anyway. Yeah, exactly. Here's another one, Cablevision. I gave them kudos a minute ago because they actually do have really good availability. Here's a case where we caught them on the 5th at 232 milliseconds over a 24-hour period. Right, 232 milliseconds in the continental U.S. over a 24-hour period, and that was on a Friday. On the Monday, when I woke up and took the measurement again, they were back down to a very reasonable 50 milliseconds or so. And I think this was at the 75th percentile. So again, we catch things like that. The idea of our open mix system is to route around stuff like that. But if you're just looking at the data, it's very interesting to see that even companies that all these companies have what I would say, or they got a network that's an organic thing that they're constantly changing, and so it's important as an enterprise to understand that and have some kind of system to hopefully route around it. Last, level 3, same thing. We had a level 3 with almost 3 times the latency on Time Warner for a day, and it fixed itself. And you can see, essentially, what the other networks were doing. Again, this is in the continental United States, 50th percentile on September 9th against all 5 of those CDNs. The last thing I'll show you was something I did. I think I mentioned we have a large news site. We've also got a very large sports site that has deployed our tag, and we've got a very large video site. So I thought it would be interesting to take a look at how the different networks treat those 3, right? Because there's a lot of talk about net neutrality, right? There's a lot of, I'm not gonna weigh in on net neutrality, but there's a lot of talk about, hey, the net should be equal for everybody. I think most of us realize it's probably not. But this is fairly interesting information. So we've got a major video site, we've got a major sports site, and we've got a major news site. And we got the entire radar community. This was at the 95th percentile on September 12th. So you can look at again, these are the major ISPs and how from that ISP, each of these pieces of infrastructure were measured from the pages of those sites. So if you take a look at the sports site, they're 100 milliseconds faster on almost every piece of infrastructure than the video site or the entire community. And the news site is not far behind. These are the major ISPs. On the what I would refer to as the rural ISPs, it's a little bit more of a wild variation. And that's actually kind of to be expected, I think. I'm sorry, go ahead. Round trip time in milliseconds from the user's browser to whatever piece of infrastructure is being measured. So in this case, on CenturyLink, the average user at 95th percentile in the continental United States was 382 milliseconds. Now again, 95th percentile for RUM, right? HTTP requests, yes. No, we have our own measurement objects on each of these pieces of information. Yes, that's possible. Certainly a video site would be, but I can promise you the sports site has a lot of video too. Perhaps, but your point is, I mean, a video site is going to need typically more bandwidth for its page anyway. But again, we're waiting until the page is completely loaded, and then we're taking our measurements. But the video is playing. That doesn't explain the entire community, right? Your point on the video sites, it's fair, but we have far more HTTP, just e-commerce sites or whatever, than video sites. Yeah. We've got a 100-byte file that we move for the throughput, and we've got just a round trip ping basically for round trip time, and availability is just attempt to connect, right? So I mean there's more because we have some SSL. We pass whether it's mobile device or whether it's broadband. Yes, it's exactly the same object on every cloud and CDN that we've deployed. So every one of our infrastructure partners have the exact same pieces of infrastructure. The interesting thing about CDNs, of course, is they've all gotten cached. Right, so they're actually living in all their caching servers. On the cloud, it's just sitting in a virtual machine on AWS or whatever. That it? All right. So the last one was, I wear glasses, and when I did this one, I wasn't wearing my glasses, and I thought, that's just because I can't see, and actually it's not. It's really fuzzy, so don't think you're going crazy. But this is the data around wireless ISPs. Sorry for the fuzzy logic. There you go. Sorry it's fuzzy, but you get the same picture, which is mostly the sports and news sites have far better performance than the entire community. And so I find that interesting. One of my projects is to aggregate this data across many more customers to create true verticals, not just one customer, because this is literally 90, these are just actually one customer each. So it's a great question. We actually built a product called SLA, and the idea, and it's not been launched yet, but the idea behind it is to monitor your infrastructure partner and then align that with an SLA. The problem is most infrastructure, and I used to be in the position where I was actually approving SLAs and then writing SLA, writing the check for the guy who had a violation. And the problem is most infrastructure companies, cloud or CDN, don't write SLAs with regard to RUM because they'd be crazy to, right? They'd be crazy. RUM's too. This is why I almost never really look at the data at 95th percentile, because when you look at the data, RUM data at 95th percentile, you're getting a lot of outliers, right? I think 75th percentile is very fair. But we do have actually one CDN partner that is now starting to write RUM-based SLAs. So I obviously hope it's a trend. I think our product really is valid anyway, in the sense of it captured, whether or not it violated an SLA, it certainly meant you had poor performance. Somebody had bad performance, right? So you want to know that anyway. And it's an alerting tool that alerts you in real time that there's problems. So. But yeah, we would like to see a movement towards providing RUM-based SLAs. I'm not sure that if I'm in the shoes of the infrastructure, my partners, I'm kind of going, oh, no way, are you crazy? But we'll see what happens, right? I mean, if enough enterprises demand it, it's going to happen. So. And I think that's it. There's a lot of micro-outages. These were all over the last month. I redacted the names, although I think I failed at completely redacting them, so I'm not going to leave you on the screen because I don't want to make anybody mad. Do I have any questions? So what we would recommend is using, this is I'm not wanting to be commercial, and we can talk offline if you want, but just briefly, we would recommend using Sedexus for that, having a multi-CDN setup so you're always getting the best performing, whatever it is that, we're going to route around that for performance, whatever the reason, right? If it's on Comcast in New York or AT&T in Atlanta or whatever, we're going to see that. And if Edgecast is performing the best on that right this second, or if Akamai is, then we're going to route you to that CDN. So that's kind of the business we're in. But you can also use that kind of DNS routing to route to endpoints, right? So you can route to your origin servers. You don't have to always route to a CDN. You can route directly to origin. And we have a lot of customers that are doing that. We have a lot of customers that are actually deploying us across. It's more prevalent on the cloud side, where they're deploying cloud services across multiple clouds, and then maybe they have their own data center, and they're using it as a global traffic management system. So, anything else? Oh gosh, someone mentioned a minute ago. There's almost an infinite amount of great data, but I will share with you what I think is one of the more interesting things we're doing. So we've started ingesting. We have APM. We have adapters, open adapters into certain APMs. So I saw Catchpoint was a sponsor. We just completed a Catchpoint. We have New Relic. We're working on a number of others right now. And what that allows our customers to do is, let's say they've got an origin that's delivering some of their dynamic data as well as CDN for the static. It lets them, monitor so they got multiple origins, right? They can monitor that using the APM. That adapter will slurp in that APM data, and then you can use it in your OpenMix script. And so you can say, okay, if this is where you're trying to go, is the utilization of those servers lower than 70%, or whatever your criteria is, and then route the traffic accordingly. So that's the biggest innovation we're doing now, is starting to pull in synthetic APM type monitoring. But in terms of this data, the stuff I'd like to correlate it with, I think correlating it with the weather is actually a pretty cool idea. I think maybe trying to figure out BGP routes and how they affect it, because they do. So there's sort of a R&D side, a Pete little play toy side that I'm not sure actually benefits anybody, but these kind of interesting conversations. And then there's a side which is the more commercial side, where we're trying to really seriously help people make sure they have the best performing app. And I think that's what you'll see out of Sodexis over the next year is doubling down on APM, our APM partners, and pulling and writing more adapters into those systems, because there's a huge value in that. We've got a number of customers using New Relic and Catchpoint now. So we do know if we do measure latency, throughput, and availability for SSL.
You talking about the video site versus the?
Yeah, but in that case, I'm not sure I care, because as long as I'm getting the average in, I know it's the. But I mean, we do know. And so some of this may get beyond my pay grade in terms of how we know, but we definitely know who the client is and where the measurements are coming from for those SSL. So we've just got a major deployment now of our radar tag on a site that is very high traffic, and it's all SSL. And so our SSL traffic is starting to really pick up. And we can get, I mean, if I go do the measurements, on my laptop, and I pull up our thing in real time, and I can pull up the SSL measurements for the community measurements, and I can get, there's not as many measurements as we have for HTTP right now, but there's an amp for the US especially, and most of Europe, there's ample number of measurements for us to have. It's data. And any data is better than no data, right? And so there's data. But yeah, I can get an answer for how we do that, but I think my understanding is it's pretty much just like what we do for HTTP.
Yeah, I'm sorry.
He's saying that on SSL, and I don't know the answer, but I do know that we get the data. But the question is, on SSL, the headers are stripped, right? But I'm not sure we're using the headers, I guess is my point. I think we're taking the measurements after page load, and that the measurements are independent of the actual web page to that degree. Sure. So if you go to our page, Sodexis.com, you can go sign up for a free account. When you sign up for the free account, there's actually a piece of JavaScript there. You can go and take that JavaScript and drop it on your page, on the bottom of your page or anywhere, and on all your pages. We hope you do. And if you did that, you wait a day or whatever, and you come back the next day, and you go, instead of seeing the entire community, because you can also log in and not even, we want you to deploy the tag, but even if you don't, you can see all the data for the entire community. Everything I showed you, you could actually pull up. Yeah, it's free. The community data, the Radar community is a free community that is made up of the infrastructure partners we have. It's made up of the websites that have deployed the tag, and that data is freely available to everybody. So we don't charge anything for it. It's just out there. But if you do deploy the tag, what you do is then there's a little radio button that says, just look at my community, or just look at my data. And if you do that, you'll see just the data from your site. And then you can compare how the data from your site compares to the entire community. And you can actually do what-if analysis and say, what if I were to add Akamai for my traffic in Asia? Bam, it gets better. Okay, so you do that. So it's a very powerful free tool for monitoring and measuring infrastructure, internet infrastructure. And it's one reason that we've grown so quickly is because you saw a lot of logos on that left-hand side. A lot of very large companies have deployed the tag because they deploy the tag because they get free data about how their website's performing. A lot of companies charge for that, right? So we're actually giving you something for free that, and then of course the value to Sodexis is we get the community data anonymized, but we can use that data then to route around problems on the internet. Yeah, there's certain networks we don't need a lot more data on. Thank you, guys.